So the numerator goes to 0, the denominator goes to, excellent. That's all I wanted. What now? So limit, x approaches 0. What is the derivative of the top? Natural log u is 1 over u times u prime. But u prime is? How much is this prime? 1. And the denominator prime is? 1. So this limit is? How much? 1. When x approaches 0, 1 over 1 is 1. So here's what I know. Limit as x approaches 0 from natural log y is 1. This so powerful result, of course under certain conditions of differentiability, continuity, and so on and so forth, I'm allowed to swap the operators. So then what will you say? Of the limit of y as x approaches 0 is 1. So therefore, what should this be? Natural log of what is 1? Natural log 1 is 0. So natural log of e and d, the same thing. They are both e. Both e. Any questions?
Yeah, good question.
Yes.
The natural log y is the limit of x plus x.
1 over x times natural log over 1 is 1 times this over x times 1. Is that okay? Yes?
So you apply the chain rule on.
I have to. Yes. Very good question. Indeed, I'm differentiating the top separately from the bottom. We never do that, except when we have 0 over 0, infinity over infinity, in a limit only. Otherwise, I would have said I'm differentiating a ratio, and I have to use the quotient rule. But when I differentiate natural log of 1 plus x, I have no choice. It's not natural log x. As long as it's not natural log x, I have to use the chain rule. I don't use the chain rule only if it's plain function, natural log x. If it has anything else, I have to use the chain rule. We are not exempt of that. We can be exempt of that. Okay, any questions? Any questions? I'm looking for my 3.6 handout, 7 handout. I'd like to start. I don't have really anything. I just said, okay, we're going to look at the rates of change. I gave you that to you last time. Change in the natural and social sciences. And I just stuck with what my department chose, only physics and economics. And we're going to choose problems. Okay? Yes. Because I need one more for Nick. It's really, I did not select. I would like you to select, and we'll select problems from. I don't want to waste time now, so Nick, I'll give you another one. So it's just, you know.
It's on the back of the.
It's on the back? Oh, is it? Okay, perfect. Okay. Yeah, I forgot that I made it back to back. That's okay. You don't have? Oh, okay then. Sorry. Okay, so let's take a look. On page, page 233, 234. I know I have only 8 minutes left, so allow me to choose. I'll choose a problem, and then we can start with problem 9. You'll see there is really nothing. If a rock is thrown vertically upward from the surface of Mars with velocity 15 meters per second, its height after t seconds is, I would like them to write this, I don't know why they don't, it's h of t equals 15t minus 1.86 t squared. What is the velocity of the rock after 2 seconds? That's part A. What is the velocity of the rock after 2 seconds? And in part B, what is the velocity of the rock when its height is 25 meters on its way up and then on its way down? So how do I determine the velocity at 2? What do I have to find first?
Find the derivative.
Yes, v of t is nothing else but h prime of t. Good? So then the answer would be 15 minus 16, 7, and 1, 3, I think. Correct me if I'm wrong. So 15 minus 3.72 t. And now I can find v of 2, which is 15 minus 3.72 times 2. If you want to give me that number, I will put it in. .44. Measurement unit.
Oh, that's not the bottom. Sorry, it's 15 minus 7.44. 7.56.
Measurement unit. So we never do this. So by the way, I just want to make sure you never ever do pieces. So you always put 15 minus 3.72 times 2. You should never ever multiply this and then subtract. No, you should do it just in one step. Okay? So, measurement unit again, I'm sorry. Very good. And in part B, we're asked to find what is the velocity of the rock when its height is 25 meters on its way up. So when the height is 25 meters. So they're asking us to find the velocity at that time when, of course, so when I'm assuming that there is gravity on Mars, so when you throw up a rock, it will eventually come back down. So the question is, how do I find the velocity of the rock when it is 25 meters above ground or above the surface of Mars and on its way up and on its way down?
So you're going to find at what time.
Exactly. So I have to solve this equation first. 15t minus 1.86 t squared equals 25. What type of equation is this and how do I solve it? Quadratic, so I have to set it equal to 0. 1.86 t squared minus 15t plus 25 equals 0. I move this to the other side, I move this to the other side. So when I move negative 1.86 t squared to the other side, it becomes positive. When I move 15t to the other side, it becomes negative. And then I will solve for t. You can use the quadratic formula, but since I'm running out of time, I am going to use my TI-86. If I find it quickly, if not, you can give me the solution. If you're using the quadratic formula. So I'm going to use the Pauli feature that I like so much in this calculator. So the coefficients are 1.86. The next one is negative 15. And the last one is 25. I click on solve. And here's what I got. I got t approximately 5.7 seconds. And the other t approximately 2.4 seconds. So I solved the equation, or you use the quadratic formula. So now I'm asked to find v of 5.7 and v of 2.4. So So this will be 15 minus 3.72 times 5.7, and this is 15 minus 3.72 times 2.4. So how much do we get? 15 minus. So I go back and I just recall what I had and times 5.7. And I got the negative 6.2 measurement unit. It doesn't mean that the velocity is negative. It means that if I consider this direction positive, then this direction will be negative. It's just a direction. So when it goes up, the direction of the velocity of the vector is going up, positive, and when it comes back, the direction is negative. That's all it means. So this is definitely on its way down, right? So this is the rock. So here's 25 meters. So this is the tangent going up, and this is the tangent going down. So because of the tangent going down, it's a negative tangent, so it's negative 6.2, negative slope. So what did we get for 2.4? Going up, it has to be positive.
6.1 meters per second.
Okay, so 6.1 meters per second. They should be okay, same thing. That's why one has a positive direction and the other one has a negative direction. So what I would like to